Hello again and welcome to 5-Minute Physics. Today's topic is resistors in parallel, and we're going to be discussing those and doing a sample question. Okay, so things about resistors in parallel. A parallel arrangement just provides alternative pathways for the movement of charge. So compared to a sequential arrangement, well, not sequential, resistors in series, which just look like this, where they're all in a nice little line. In parallel, they look like this, where there are multiple pathways. Where say that your battery was here. You got a battery there. You could go like this and across. But you could also go like this and across, and the same way with all the others. Okay. So things about resistors. Resistors in parallel have the same potential differences across them. So no matter the arrangement, they always have the same potential difference across them. And the sum of the currents in parallel resistors is always equal to the total current. So keep that in mind. And the equivalent resistance, which we'll be solving for in a moment here, the equivalent resistance for a parallel arrangement is always less than the smallest resistance of the resistors. Always less. So if you have a 2, a 4, and a 7, it's always going to be less than the 2, less than the smallest. Alright, so let's go to our sample problem. A 9-volt battery is connected to 4 resistors. Find the equivalent resistance for the circuit and the total current in the circuit. Okay, that's fairly straightforward. So let's go to our schematic. There we go, it's down on the bottom. There's our schematic. We have our power source here, our battery. And here's resistor 1 with a resistance of 2 ohms. Resistor 2 with a resistance of 4 ohms. Resistor 3 with a resistor of 5 ohms. And resistor 4 with a resistance of 7 ohms. And our battery is a 9-volt battery. So let's go to our give and find. Okay. To set up this question, we gotta first always do the give and find. It's very helpful. Okay, so we have delta V is equal to 9 volts. That's our battery. R1, our first resistor, is equal to 2 ohms. R2, if I can write this properly, is equal to 4 ohms. R3 is equal to 5 ohms. And R4 is equal to 7 ohms. Alright, now what are we looking for? What do we need to find? We're solving for the equivalent resistance and for the current, the total current, and that is I. And so the equation we're going to use is the same one that we used for solving for resistors in series. For solving that one is delta V equal to I times the equivalent resistance. And the other equation to solve for I, I'm going to set it equal to I. I is equal to delta V over equivalent resistance. And that's just a rearrangement of this equation right here. Okay, so let's start solving this. We've got our first equation. Our delta V equal to I times equivalent resistance. So, first we need to find the equivalent resistance. Now, for resistors in parallel, as opposed to resistors in series, this is calculated with 1 over the resistor value. So in resistors in series, you just add them up, but for resistors in parallel, you need to use the inverses. So in order to find that, equivalent resistance in order to plug it into our other equation, we'd have 1 over the 2 plus 1 over the 4. That is very hard to read. Plus 1 over the 5 plus 1 over the 7. And that comes out to 1 ohm over 1.09. So that's our equivalent resistance. Okay? Now we solve for I. So I lied, we're not actually using this one, we're using the rearranged version. I equal to delta V over equivalent resistance. And so for that, we're going to use our equivalent resistance delta V, our delta V up here, 9, or 9.0 volts, over what we just calculated, the inverse of this, which I should have written, which is 0.917 ohms. So this is the actual answer, not that one. Alright, so we'll plug that in. That's 0.917 ohms. And then we'll solve this, and we end up with 9.8 amps. And that is our answer. That is the current moving through this system, the total current. And remember that when resistors are in parallel, the equivalent resistance should always be less than the smallest resistance. So let's see, our equivalent resistance was 0.917. What's our smallest? 2? Is that less? Yes, it is. We're okay. Alright. This has been another episode of 5 Minute Physics. Thanks for watching, and we'll see you next time.